So this paper, I see a box there, I don't know what it is, but anyway, this is a paper on the commodity price supercycle. And the commodity price supercycle is a feature of commodity prices, which is that they display very long cyclical movements. And our observation is that the literature, the existing literature has focused mostly on characterizing the supercycle, that is to say, characterizing its amplitude, its frequency, etc. And there is much less work on how important the supercycle is for explaining aggregate activity in developed and emerging countries. And this is what the gap that our paper aims to fill. So just to give you a feeling for what the commodity price supercycle is, here's a graph of 11 commodity prices. The World Bank, this data is from the World Bank. The World Bank has more disaggregated data. I think it's up to 45 prices or something like that. But for the purpose of our analysis, which is going to be a structural analysis, structural empirical analysis, 11 is, I think, enough. The disaggregation going beyond that would be counterproductive. Let me see if I can do something to get that box out of there. No, I think, oh, it went. Okay, so what you see here is this regular cycles on top of very long cycles here. So there is, for example, this first cycle here that took place in the 70s, even 60s, and peaked in 1980. It was associated with all the development with oil. And then there is another that started in the late 90s, early 2000s with reforms in China and peaking here around between 2010 and 2015 with actually slightly before the global financial crisis, so slightly before 2010. And then on top of those long cycles, you have these regular cycles. So what we want to do today is to distinguish, try to find an econometric approach to identify this long cycle, this commodity price supercycle, also identify these shorter cycles, make them compete with shocks, permanent and transitory shocks that could be going on also in emerging, domestically in the different countries, and make all of those shocks compete for output growth, for explaining the growth rate of output, and see whether the ultimate question that we have is whether this super cycle is important for aggregate activity, because the narrative that one encounters in formal discussions is that they are. So we were curious to see whether that is indeed the case. So our identification approach is going to be to identify the commodity price supercycle with the permanent component of commodity prices. It's a common permanent component to all commodity prices. And that differs from the existing literature that has focused, for example, on spectral analysis or HP filtering and things like that. And I think that our common permanent component approach has two advantages. One is that it delivers a single commodity price supercycle, which is, I think, of interest because of this feature of the data. Commodity prices seem to be, in the long run, moving more or less in tandem. They don't, diverge one from one another. So I think it's a relevant identification assumption to assume that there's a common permanent component. And second, because we are going to do it in a structural fashion, it will allow us to identify and evaluate the importance of the commodity price supercycle in conjunction, that is to say, competing with other shocks, possibly foreign shocks and domestic shocks. So that is the idea. Let me show you, I'm gonna, for 1 second, close my video because I'm getting this sign that the connectivity is a bit unstable. So just to make sure that I don't lose you guys, I'm gonna just put the photo there until I finish the presentation. So this is the model is going to be an empirical, structural but empirical model with a foreign block and a domestic block. And the foreign block is going to have a bunch of prices, which are going to be summarized in this vector P. So this vector P is going to have the 11 commodity prices that I showed you before, plus the world real interest rate, basically the real interest rate in the United States. And we will assume that there is this non-stationary shock called XPT, which is non-stationary, that is to say, it's a permanent shock, stochastic shock, that is common to all prices, such that if I subtract this XP from any of the elements in P, except for the world interest rate, any commodity price, the difference becomes stationary. So this is going to be basically the permanent component. XPT is going to be the permanent component of the commodity prices, right? So if I have, for example, P1 minus XP or P2 minus XP and so on, all of these variables that I'm going to refer to with the hat, P hat T, these deviations from trend, if you want, are going to be stationary. So this XP, being the permanent component of the commodity prices, is going to be our measure of the commodity price supercycle, right? So this XP is going to be our measure of the commodity price supercycle. And then we're going to put some structure on the evolution of this cyclical component of PT. So this P hat T is the cyclical component of the commodity prices. The deviations from the commodity price supercycle, we're going to assume that that has a autoregressive portion here, that it depends on the growth rate of the trend here, delta XPT, the growth rate of the commodity price supercycle. And we're going to assume that there's a bunch of stationary shocks, ZPT. This is a vector of 12 stationary shocks that can also affect the commodity prices, right? And these ZP that are stationary are meant to capture, let me see if I can move here. It's meant to capture this shorter term variation here, right? Which are on top of this supercycle, right? Those are these variations here are the ZPs, okay? So we have that commodity price supercycle, the permanent component, and we have these shocks here. And our aim is to estimate these matrices B, C1, C2, and so on. The problem is that we don't observe anything here. We don't observe P hat, the cyclical component, because we don't observe the supercycle. We don't observe this object here, XP. We don't observe, again, delta XP, and we don't observe ZP. So nothing here is observable. So I will have to do something later on to bring this equation to the data, but as it is, it cannot be estimated. The domestic block is going to be similar for each country. We are going to have a bunch of countries, more than 20 countries. In one case, more than 40 countries. The object of interest is going to be real output. Okay, so why IT is going to be real output in country I in period T. And we will assume that this output is driven not only by the foreign shocks, the commodity price supercycle and the stationary foreign shocks, but also by domestic shocks. And these domestic shocks also come in two flavors. There will be a domestic shock that is country specific, that is non-stationary. And this shock, I'll show you in a second which properties it has. And the second shock, domestic shock, is going to be a stationary shock. Okay, so each country has a permanent trend shock, if you want to, and a transitory shock, ZIT. So this permanent shock, XIT, is going to have the property that if I subtract from country one, for example, X1T, and I subtract a fraction alpha of the commodity price supercycle, the difference is stationary. So the cyclical component of output in country one is output in country one minus this permanent domestic shock minus a fraction alpha one of the commodity price supercycle. The reason why we allow these two shocks to be part of the trend, in particular why we allow this commodity price supercycle to be part of the trend, is because commodity prices act a little bit like productivity shocks. So a productivity shock that is permanent will be part of the trend in output. So this permanent component of commodity prices here, we allow them to be in the trend, but multiplied by alpha, and we are going to estimate this alpha. So for each country, there will be a different alpha. So this commodity price supercycle is going to enter the trend of output with different intensities. And then we're going to put some structure to this cyclical component of output in each country. So this vector Y is going to include the cyclical component of output in all countries. And we're going to assume again that it has a autoregressive part here, that it depends on past commodity prices, that it depends on the growth rate of the commodity price supercycle, on the stationary world shocks, ZP, on the growth rate of the domestic trend, so this will be like a domestic trend shock, and on the domestic, if you want, like stationary shock, ZT here. Okay, so output in each country, just to summarize, is going to be the cyclical component of output in each country. It's going to have this autoregressive part, but it's also going to depend on both sets of shocks. The foreign shocks, the growth rate of the commodity price supercycle, the foreign shock, the stationary foreign shocks, and then on the two domestic shocks, one stationary and one one non-stationary and one stationary. Okay, so having put that structure, again, nothing in this equation is observable. Okay, so I don't observe the cyclical component of output. I don't observe the cyclical component of prices. I don't observe these shocks. So nothing here is observable. So again, we will have to do something to bring this equation to the data. Now, how do the shocks, this is the growth rate of the commodity price supercycle. This is the growth rate of the domestic non-stationary shock. And these are the two stationary shocks, the foreign stationary shocks and the domestic stationary shocks. We're going to put them all in a vector, and we are going to assume that that vector follows an AR1 process like this. Okay, so now we have the two structural equations, this one for output, this one for the commodity prices and the world interest rate, and we have the evolution of the driving forces, right? Two non-stationary shocks, one foreign, one domestic, two stationary shocks, one foreign, one domestic. Okay, so in fact, this is a bunch of shocks. Okay, so how are we going to estimate this model? Well, we are going to assume that we can observe, we have the ability to observe the growth rate of the commodity prices, right? We can get data for commodity prices from the World Bank, take the growth rate of the real commodity prices, and we're going to assume that that can be observed without any problem. We're also going to assume that we have the ability to observe the growth rate of output. Right? We go to the statistical agency of the country, we download data for output, we take the growth rate, and we assume that we can observe that. We also assume that we have the ability to observe the world interest rate. So our data is going to be this. It's going to be the growth rate of 11 commodity prices, the growth rate of output in a bunch of countries, and the world interest rate. And then how do we link this data to the unobservable variables of the model? Well, by identities. The growth rate of the commodity price is the growth rate of the cyclical component of the commodity price, plus the growth rate of its trend, which is the commodity price supercycle. Similarly, the growth rate of output, by definition, is the growth rate of its cyclical component, plus the growth rate of its trend. And its trend has a domestic component, delta X, and a foreign component, which is delta XP. These are just identities. But these identities are useful because they link objects that we do observe with objects that we don't observe. So from these identities, we can infer, knowing the structure of the model, this and this, we can calculate the likely observation on this data, and knowing how they link to these unobservable variables, we can infer, for example, using the Kalman filter. It's not the only way, but one way to do it is to use the Kalman filter to infer what is the likelihood of this data. And once you have the likelihood of the data, you can make all sorts of inference, right? You can compute, estimate the model, for example, estimate all of the matrices that define this structural model. Okay, so let me now show you some results. I have, I guess, 7 minutes, right? Something like that. How much time do I have left? Okay.
You have more or less 7 minutes. Go on.
All right, thank you. So we are going to start with OECD data, which the reason why we use OECD data is because it has quarterly data for very long periods of time on output. So we have good quality, long spans of real output data. And the problem is that the OECD has mostly developed countries. And we want to also include emerging countries. It has some emerging country data, for example, Mexico, South Africa, Turkey. And it also has data from countries that in the 60s and 70s were, and even 80s, were considered emerging countries, like South Korea is also in the OECD, peripheral European countries like Portugal and Spain are also there. So there are a bunch of emerging countries, not as many as we would like, but the data is very good. I'm going to later talk about emerging countries. But for the time being, we're going to take all of the OECD countries except the large countries. We're going to exclude the US and Germany because we want to deal with small open economies. Why? Because we want countries that take commodity prices as given. That cannot be said about large economies like the US. So we're going to get the US out of the OECD group. Okay, so the data is data, as I told you, quarterly from 1960 to 2018. The commodity prices are the 11 commodity prices that I showed you. The aggregation is the aggregation of, for example, gas or oil, right? It's not disaggregated in different types of oil. Agricultural commodities. We are not going to talk about wheat and something like that. So the aggregation is the 11th commodity price aggregation given by the World Bank. The world variables, as I said, are the commodity prices, the world interest rate, and the country variable is the growth rate of output, right? As I showed you in the model. First, let me show you how the commodity price supercycle looks like once you estimate it. So we estimated using this methodology I explained, this permanent component of the commodity price that we call XP, and it looks like this. This is, reassuring in the sense that it tracks the data pretty well, but it's a smoother version of the data, which makes sense because this is a trend. It's a stochastic trend. It changes from period to period. But that is what we call the supercycle, right? This blue thick line is a supercycle. This supercycle explains about 27%, that's the number, 27% of variations in this commodity prices. So it's not a negligible part of the variance of commodity prices explained by this commodity price supercycle. This is the main result of the paper. So we present the results in many, many, many ways, but I decided for this talk to deliver it to you in just one line, which is, if you look at the variance of output growth, how is it decomposed into the different shocks in the model? So the most important shock, the one we are interested in, is the commodity price supercycle. It's this XP shock, which is this blue line here, the growth rate of that. And that one explains only 8% of the variance of output growth. So we say, look, 8% is not zero, but it's not a dominant role that it plays in explaining the growth rate of output. Now you can cut this pie here in different ways. The first way I would like to cut it is the one I just mentioned. The commodity price supercycle doesn't seem to play a dominant role in explaining output growth. The second way to cut this pie here is to say, well, how important are foreign shocks, which are the first two columns, versus domestic shocks, which are the last two columns. And what you see here is that foreign shocks explain about 70% of the variance of output growth, whereas domestic shock explain only 30%. So that is the second message of the paper. Foreign shocks are very important in explaining output growth. The third way of cutting this pie is to divide shocks into permanent, the foreign permanent shock, and the domestic permanent shocks. You can call those the trend shocks, and ask how important are those relative to standard stationary shocks, the foreign stationary shock and the domestic stationary shock. And the answer there is that stationary shocks are much more important than trend shocks. Okay, so that's the third message of this table. First, the commodity price supercycle doesn't seem to be that important in explaining output growth. Second, foreign shocks are more important than domestic shocks. And third, trend shocks are less important than standard stationary shocks. I haven't heard any bells yet, so I guess I have more than 5 minutes still.
Yes, you have.
Okay, let me quickly talk about emerging countries. So I told you that the OECD data has at most 5 emerging countries. We wanted to have a larger sample of emerging countries. For that, we had to sacrifice frequency. We had to go to annual frequency. In that way, we could get more data on emerging countries. The coverage is the same, is 1960 to now, maybe 2018. And now we have many, many more emerging countries. We have a very nice set of emerging countries. We pick only emerging countries for which we could have a whole sample from 1960. But otherwise, besides technical adjustments, the model is exactly the same. For example, we are using annual data, so we can no longer use 4 lags, we use only 1 lag. And we cannot use such a disaggregated commodity price data. We aggregate the commodity prices into only 3 commodity prices. But the structure of the model is exactly the same. Let me show you. These are only 3 commodity prices, which are these 3 shown here. So we have metals, non-metals, and so on. Okay, so I have 5 minutes. And this is our new estimate now of the commodity price supercycle. Is again this blue line. And as before, this blue line is like a stationary version, or a more stationary, a less volatile version of some kind of long-term trend in the commodity price. So it captures the long-run kind of movement in these commodity prices quite well. So jumping from an 11 commodity price version to a 3 commodity price version kind of delivers a robust result there. And let me also summarize our result with emerging countries with only one line. Again, I'm going to ask what is the composition of the variance of output growth over the different shocks in the model. And this is the mean over all the emerging countries. And what you see is that the role of the commodity price supercycle is a little bit higher. This is expected because now the data is very aggregated. So when you aggregate data, you basically kill all the high frequency shocks. So this guy gets it in the chin, the stationary shock, and the non-stationary shock, the commodity price supercycle, gains a little bit of bite here, but it's still not the dominant role. It's less than 20%, less than 1/5. And all the other results more or less are maintained. If one considers the caveat that this data is much more aggregated, in the sense that foreign shocks seem to be more important than domestic shocks, and that stationary shocks are more important than trend shocks, although here the difference is a bit less. But the basic results that we got with much better quarterly data, OECD data, maintains here or carries over to this data set with many more emerging countries, but performed on an annual basis. Okay, so I'm going to conclude. What we did in this paper was to start from the observation that there's not much work done on how important is the commodity price supercycle in explaining variations in real activity in emerging and developed countries. This paper aims to fill that gap. What we propose is estimating the commodity price supercycle as the permanent common component to all commodity prices. We estimate a structural model that makes this shock compete with other shocks, stationary foreign shocks, and stationary and non-stationary domestic shocks. And what we find is that the commodity price supercycle plays a role. It's not a negligible role, but it's not a dominant role in explaining output in emerging countries. So we feel that the narrative that is out there is a little bit exaggerated in the sense that it attributes a much bigger role to the commodity price supercycle in explaining aggregate activity than it deserves. Much more attention, I think, policymakers should play to cyclical movements in commodity prices, right? These world shocks, including the interest rate, but stationary cyclical movements in commodity prices and the interest rate play a much more important role in explaining output variations than the commodity price supercycle. So I'm going to stop here because I think I'm on time.